Well, this example actually demonstrates the addition of vectors by using the two-dimensional motion. And in this example, a person drives his car by heading towards south, as shown in the figure, with a speed of 20 meters per second and for 3 minutes time. And then he changed his direction to the west and start driving with 25 meter per second speed to the west for 2 minutes time, and afterwards he changes direction due to northwest with obviously the word northwest means that 45 degrees north of west or west of north, 30 with the speed of 30 meter per second, and it takes him 1 minute time in this this last displacement. So the whole trip takes 6 minutes, and what we want to do, we want to find the total vector displacement, obviously out of these 3 displacement vectors. And then in part B, we have to find the average velocity, and we'll compare that with the average speed. And in this example, it's good to see the difference between the average speed and the average velocity. From the information we have about the velocity in each time, we can find the displacement in each phase. The first displacement is simply the product of the speed, which is 20 meters per second multiplied by 3 minutes. This is 3,600 meters due south. The second displacement, also the product of the speed, which is 25 meters per second by 2 minutes, and then we're going to get 3,000 meters. And the last displacement is 30 meters per second by 1 minute, and we're going to get 1,800 meters. It's obvious that we convert the minute to seconds in order to get this final answer. And now the sketch of total displacement will replace that of the velocities in the diagram. Now, in each phase of the motion of the car, we can find the displacement and its direction as shown in the diagram. And in the first displacement A, we have a magnitude of displacement 3,600, and this makes an angle of 270 with respect to the positive x-axis, obviously. And then the second displacement B is with 3,000 meters and also makes an angle of 180 degrees with the positive x-axis. And that's why we got here the x component with a minus sign, while in the case of A displacement, we got the y component with a minus sign, which indicates that the y components in A going downward, while the B component, the x component, going westward. And finally, the last displacement called C, with a magnitude of 1,800 meters. It has an angle of 135 degrees with respect to the positive x-axis. And to find the components here, we're going to get an x component for the C as minus 1,272, while the y component is positive, as you can see, the vector, the y component is heading north, while the x component is heading towards west. By taking the, in order to take the resultant of this displacement, we'll take the addition of the x component, including the signs, and the y components, including the signs. Now we end up with an x component with a negative sign, that's q west, with 4,272.8 meter, and with now the diagram shows the successive displacement at head to tail vectors adding together, and we have to find the resultant r of these displacement, which represents the total displacement. To do that, we have to write the resultant vector as a vector in terms of unit vector notation. So we found Rx and we found Ry. Just insert them into this equation, vector equation, going to get the vector equation in terms of unit vector I hat and j hat. To find the magnitude of the resultant, simply take the Pythagorean theorem, and we're going to get this 4,870 meters. To get the angle, divide the y component by the x component, and you're going to get an angle of 209 degrees with respect to the positive x-axis. Well, the average velocity, as its definition says, is the displacement by time interval. Now, we have a time interval of 6 minutes for the whole trip, while the displacement vector is obtained in terms of I hat and j hat. What we have to do, we have just to divide that by the time after conversion to seconds, and we'll get two components for the average velocity, one along the x-axis with minus 11.8 and one along the y-axis with minus 6.5 meters per second. Obviously this vector is with its two negative signs, it's in the third quadrant. To take the magnitude of this, just having the x component squared and then the y component squared, add them together and take the square root, you're going to get a magnitude of the average velocity of 13.5 meters per second. To get the angle, just the angle as defined here is tan inverse of the average of the y component divided by the x component. We're going to include the y component, include the sign with the y component and the sign of the x component as well, as long as they are both negative. Then you're going to get an answer of 209, which is the same as that obtained for displacement, of course, and that is expected. An alternative way of getting the magnitude of the average velocity, we can do that by having the displacement vector at the beginning and use that to get the absolute magnitude of the resultant and use the Pythagorean theorem to get the magnitude. And then after getting the magnitude, divide that magnitude of 4,870 meters by the time interval of 360. You will get a similar answer of 13.5 meters per second for the magnitude of the velocity. In order to get the average speed, which is a scalar quantity and defined as the total distance over the elapsed time, we need to find the total distance. To do that, we will get the magnitudes of each phase of displacement in the trip. The first one with 3,600 meters, and the second one B with 3,000 meters, and the third one with 1,800 meters. Add them all together, we'll get the total distance of 8,400 meters. This is nothing to do with here. this distance, nothing to do with directions, because the average speed, as we said, is a scalar quantity. So to get the total time of the trip is 6 minutes multiplied by 60 to convert it to seconds, and then divide the total distance of 8,400 meters by the elapsed time of 360 seconds. You're going to get an answer of 23.3 meter per second. The value here represents a scalar quantity. There is no sign at all. There is no any angle at all, because the average speed again is a scalar quantity, and that is different from the average velocity, which has a magnitude of 13.3 meter per second and direction with 209 degrees.